Hello, math students. Welcome back to our module called Linear Equations. This is Lesson 7, Classifications of Solutions. The goal for today we will learn what happens when we get solutions other than just one solution. The question that I want you to be thinking about is, are there any things to look for when classifying solutions? If so, what? All right, so what I am talking about when I say get solutions other than just one solution. So far, when we have been working at solving for a variable, we have come up with the result that there is always one value for your variable. We've been working on x, so I'm just going to say there has been one value for x. But sometimes when you are working with linear equations, you will end up with some different solutions. You will have one solution where the variable is equal to exactly one value, and then you'll have a couple of other situations that result, and we're going to talk about those today. So taking a closer look, first thing that I want you to do is solve for the variable x. So I'm going to help you start, and we're going to use the same skills that we've been doing all along to try to solve for x. So in this very first one, we see that we have variables on both sides of the equal sign, and so we have to get the variables all to one side. And for me, I know I've shared with you that I like to move the variables from one side to the other. I'm going to take the 2x. Right now it's a positive 2x, so if I subtract 2x from both sides, then what that creates on the left-hand side of the equation is a zero pair, which is what I'm seeking. And then what you do to one side, you have to do to the other. So on this side, I'm left with 5x. Bring down the minus 8, bring down the equal side, and now I'm left with this. So now what I can do is I can use my BU chart, and my variable is x. I multiplied by 5, and I subtracted 8. So to undo that, I need to add 8, divide by 5, and I'm left with x. So when I add 8 to both sides of my equation, this side creates a zero pair, so that's good. Now I'm left with 5x on the right-hand side of the equation, and I'm left with 15 on the left-hand side, and now I have to divide both sides by 5. 5 divided by 5 is 1, 1 times x is x, and 15 divided by 5 is 3. So I have found that in this equation right here, the only value for x is 3. Okay, so now let's try the middle one, doing the same steps and see what happens. So again, I have x's on both sides, so again, I'm going to subtract 2x from both sides. This side creates a zero pair, which is what I need. This side creates 7x minus 2x, which equals 5x, plus 7 equals 7. And now I use my BU chart, just like I did previously. My variable is x. First thing that I did to it was I multiplied it by 5. Then I added 7, so I have to subtract 7, divide by 5, and I'll be left with x. So I'm going to subtract 7 from both sides. This one creates a zero pair. This one creates a zero pair. So the only thing that I'm left with is 0 equals 5x. So now it says that I'm supposed to divide both sides by 5. 5 divided by 5 equals 1. 1 times x equals x. 0 divided by 5, and you can't do that. So you cannot take 0 and divide it by 5 because 0 holds no value. So this is called no solution. And the reason why it's called no solution is because you cannot take 0 and divide it by 5. So this one would be no solution. It's not possible. We can also write not possible. Okay, so that's different. All right, so now let's try it one more time. And it says that I am supposed to, again, have x's on both sides, so I need to get the x's together. The only thing that's weird about this one is that they're the exact same, so it doesn't really matter which one we move. So subtract 2x from both sides, and I get a zero pair here, and I get a zero pair here, So I'm left with 7 equals 7, and I don't have any more variables. So it's already solved. Okay, so what this one means is that x could be any number. Let's try it. What if x equals 1? So we have 2 times 1 plus 7 equals 7 plus 2 times 1. 2 times 1 is 2 plus 7 is 9. 2 times 1 is 2 plus 7 equals 9. Wow, that's interesting. Okay, what if x equaled 23? So 2 times 23 plus 7 equals 7 plus 2 times 23. Well, I know that 23 times 2 is 46, right? 46 plus 7. And then I get 53. And then over here, I have 2 times 23 is 46 plus 7. And I know that those two together equal 53. Oh my goodness, what is happening here? So what we have just proven for this one is that there are infinitely many solutions. And we proved that because 1 worked, 23 worked, subtracting off the x values to combine them works. So really weird. This one over here, the only value that we could come up with that would work is x equals 3. So we call this one solution. Whereas this one is not possible because you can never have a dividend of 0 because 0 cannot be divided by anything. I'm sure all of you have typed into Siri 0 divided by 0, and you got the Cookie Monster story about him being sad because you can't divide 0 cookies because you have no cookies to begin with. So 0 cannot be divided by anything. And so that one's no solution. And then this one is infinitely many. We could choose any number, and plug it into this original equation, and it would still come out equal. So what you have just seen, kiddos, is that there is a possibility when you have linear equations that you could have exactly one solution, no solution at all, or infinitely many solutions. Okay, and so those are addressing what happens when you get more than one solution that the variable can just equal one answer. So it really does exist. What do you notice about the 3 equations? The 3 equations have things in common. So for example, this said 2x and 7x, this said 2x and 7x, this said 2x and 2x. So that one's a little bit different. This one said plus 7 minus 8. This one said plus 7 plus 7. This one said plus 7 plus 7. So again, different subtleties. What do you notice about the 3 equations? The thing that I notice about the 3 equations is that even though they share the same terms, comma, the way they are arranged makes them have different solutions, which is true. Okay, interesting. All right, so now the next part is the 3 types of solutions, and these are the 3 types of solutions. So one solution means that there is exactly one numerical value for the variable. And this is what you have been learning about all along. Okay, so we've been working with one solutions all along with learning the whole process of solving them. Okay, no solution means that the value for x cannot be found. No solution, the value of the variable cannot be found or determined. For example, 0 as the dividend. I'm going to write that down. 0 as the dividend. As long as 0 is the dividend, you will never find a solution, okay? And then infinitely many solutions means that the value of x could be anything, infinitely many, so infinity. You know, you guys have loved playing with those words. Well, this is where it's applicable. So infinitely many solution means that any number could be the variable because when substituted, the expressions are always balanced. Okay. So then those are the three different types of solutions that we have. There are some things that you can look at that will give you telltale signs that you're either going to have one solution, no solution, or infinitely many. So let's go back up to these three examples because I really want to point this part out because it's really, really important. And so what I want to show you is that you can see some patterns within the problems themselves, and those patterns will help you know what kind of answer you're going to get. This original equation looked like this: 2x plus 7 equals 7x minus 8. So the reason, or the things that you can look for when you're looking for one solution answers, is if your constants are different. See how those are the constants? And then your coefficients are different. So if your coefficients are different and your constants are different, you're going to probably get a one solution as the answer. This one, however, 2x plus 7 equals 7x plus 7. This one is no solution at all. And the reason why this one is no solution at all is because your constants are equal. And what I'm talking about is this guy right here. Because these both equal 7, guaranteed when you try to combine them, you're going to get a 0 as an answer. And then when you get a 0 as an answer, no matter what you're trying to divide by, 0 would become your dividend, and then that makes it no solution. So a way to remember no solution is that if your constants are exactly the same, you're going to have no solution. So on this one, the constants are different, and then your coefficients are different. This one, your coefficients are different, but your constants are the same. So when your constants are the same, you're going to have no solution. When your constants are different and your coefficients are different, you're going to have a solution. Okay? And then the last one to look at is you had, this is your original problem, 2x plus 7 equals 7 plus 2x. Well, you're already looking at infinitely many because what do you notice? You know that your constants are exactly the same, so that should automatically tell you no solution. However, the reason it doesn't say no solution is because they also have the exact same coefficients. Okay? So when you're looking at an infinitely many solution, if your coefficients are exactly the same and your constants are exactly the same, then you're looking at an infinitely many solution, because no matter how you change the coefficient term, it's always going to be the same because you have the same variable being changed by the same amount. And then you're adding the same thing. So nothing really is changing at all in your equation. So you have infinitely many, where everything is exactly the same on each side of the equal sign. You have no solution when you have different coefficient terms but exactly the same constants. And then you have exactly one solution when everything is different. Okay, so that's another way to keep the three different types of solutions straight. Okay, all right, kiddos, that's all I have for you. Let's review. Sorry, I had to make sure there was nothing on the back. The goal. Today we will learn what happens when we get solutions other than just one solution, which we did. The question that I asked you to think about is, Are there things to look for when classifying solutions? If so, then what? I would definitely say the things to look for are when you're actually looking at the makeup of your equation. If your coefficients are different and your constants are different, you're probably going to get one solution. If your coefficients are different but your constants are the same, you're probably going to get no solution. And if your coefficients are the same and your constants are the same, then you're definitely going to get infinitely many solutions. Okay? So that's how we determine the classifications of different equations. That's all I have for you. Talk to you soon. Bye.